Alright, so this will be the last shape that we cover in Chapter 9, and this one's on parabolas. And we've already studied parabolas in the fall, but we're going to take a different approach to them now, because parabolas, it turns out, also have focus points. Each parabola has its own focus point, and that's inside the parabola, inside the arc. And then outside the arc, there's a line called the Directrix. Right? It's not Directrix, it's just Directrix. And it turns out that the way that the focus and Directrix are related to parabola, that if you pick a point on the parabola, then the distance to get to the focus is the same as the distance it takes to get to the line. So these two blue chunks would be equal to each other. If I pick some other point, like the one over here, well, the distance to the focus right there is the same as the distance to the Directrix down here. So these two guys are the same. So we're going to use that property to help us figure out a way of writing the equation of the parabola relating it to the focus and Directrix. Okay, so what's the distance formula? All right, well, to refresh, the distance between 2 points, so let's say between x1, y1 and x2, y2, is going to be given by d equals, and then remember it's this square root x2 minus x1 squared plus y2 minus y1 squared. So now we're going to use this with a specific example, and then we'll develop a general formula that we can use. So in the example, we've got the focus point here at 0, 2, so I'm going to turn that into an x because I like using x's for focus points. The directrix is down here at y equals -2. If we had to figure out what the vertex is, well, we know that from here to here is 2 units and here to here is 2 units. So this point right here is going to be on my parabola. And then the parabola always opens towards the focus. If you notice up here, there's the focus. The parabola kind of cradles the focus. So that's what we've got here. We've got some picture that looks like this. Right, let me fix that side of the parabola a little bit more. So it looks like that. So the vertex is going to be at 0, 0. And I'll just tell you now, every single problem we're going to do, the vertex, including, we're never going to move it around. It's always going to be at 0, 0. Okay, so let's come up with the equation. And the way we're going to do that is we're going to pick a random point on the parabola. And instead of figuring out exactly where that is, I'm just going to say, well, it's at xy. Okay, so then we're going to figure out how can we express this distance, and then we know that that distance is supposed to be the same as this distance here, right? So let's do this. Let's figure out this one going sideways here first, okay? So I'll call this point, so we want the distance between xy and 0, 2. Okay. So I'll make this one the x2, y2, and this one the x1, y1. And so then the distance between them is going to be x2, which is x, minus x1, which is 0, squared, plus y2, which is y, minus y1, which is 2, squared. And then on the other side here, we need this distance. Well, we don't know the coordinate of its endpoint. What we do know is that the y value has to be -2 because it's on the line y equals -2. So it's something -2. And then the x value, well, if you go straight up, this point had an x value of x. When you go up and down, the x's don't change. So this one really just has a coordinate of x also. So what we want now is the distance between the point xy and x -2. So I'll call this one x2, y2, and this one will be the x1, y1. And when we plug into the distance formula, it's x2 minus x1, which is x minus x squared, plus y2 minus y1, so minus -2 squared. And then we know that these distances are supposed to be equal to each other because that's how a parabola works with its focus and directrix. So equals. And before I try to simplify stuff, if you notice here, this is x minus x. Well, that's 0 squared, so that just goes away. This is x minus 0, so that's really just x squared, so I can kind of ignore that 0. So if we simplify a little bit, first we've got root x squared plus y minus 2 all squared equals root, and then on this side it's just y plus 2 squared. So now what I'm going to do is I'm going to square both sides, and when you square a root, you just get the inside. So it's x squared plus y minus 2 squared equals y plus 2 squared. Right? Okay, well, I want to FOIL out the y minus 2 squared and the y plus 2 squared. So I'm going to write it like this, y minus 2, y minus 2. And then over here I'll write y plus 2, y plus 2. So it's easy to remember, you get middle terms. So then when I FOIL out the y minus 2, y minus 2, you get a y squared, and then minus a 2y and minus another 2y, so minus 4y. And then negative 2 times negative 2 is plus 4. And then on this side we'll get a y squared plus 2y is plus 4y, and then plus 4. And now some more stuff cancels. The 4's on each side cancel, the y squareds on each side cancel. And then if I add 4y to both sides, I get x squared equals 8y. And I know you're more used to writing y equals, but for some reason when you're thinking about the focus and directrix, for some reason textbooks like to write x squared equals something. Okay, so we're actually going to leave it in this form here. Let's take a look at number 3. Now, if you notice, number 3 is just like number 2, except instead of 0, 2, we're using a general focus point, 0p. And instead of the directrix being negative 2, it's going to be negative p. So we're basically going to do the same problem, but 2's turn into p's. So let's graph a sample picture for it. So the focus will be at 0p. The directrix will be at y equals negative p. And then if you think about a point that's definitely the same distance between those two things, 0, 0's the easiest one. So that's our vertex right there. Vertex 0, 0. And then it's going to curve out like this, because it always cradles the focus point. I'll label this directrix, dir there. Okay. So let's see what we got. We'll pick a general point, some point right here, call it xy. And then let's figure out that distance between that point and the focus. And I didn't draw this very well, but this is supposed to be the same distance too. Okay, so, whoops. So first let's figure out the distance between xy and the focus point. So xy to 0p. And I'm going to call this x2, y2, and this one x1, y1. And when we set up our distance formula, we'll get x2 minus x1 squared plus y2, which is y, minus y1, which is p squared. And then if I do the same thing for this part right here, well, this point, the x-coordinate's the same as the one right above it, so that's x. And then the y-coordinate down here is negative p, because all the y's on that directrix have the value of negative p. So we're looking here for xy, the distance from xy to x negative p. So we're going to call this one x2, y2, this one x1, y1. Then we'll plug it into the distance formula and we'll get x minus x squared, that's x2 minus x1, and then y2 minus y1 will be y minus negative p, so y plus p all squared. Okay, now once again, we've got x minus x here, so that turns into 0. We've got a minus 0 inside this parenthesis, so we can just ignore it. And then if I rewrite this, we get square root x squared plus y minus p all squared equals square root y plus p squared. So now I'll square both sides. and get rid of those roots. And then I'm going to want to FOIL out the y minus p squared. So first let me write it like this so it's easier to see what we're doing. And this is going to turn into x squared plus, and then when we FOIL, y squared minus, and then a py and another negative py, so minus 2py. And then negative p times negative p will be plus p squared. And then on this side, we'll get a y squared, and then a py and another py, so plus 2py, and then plus p squared. And then once again, stuff cancels. P squareds cancel, y squareds cancel. So if I add 2py to both sides, I'll get x squared equals 4py. And that's actually the form right here that we want. Okay, so now we know if we've got a focus point 0p, a vertex at 0, 0, and a directrix y equals negative p, this guy right here is the equation that will set up the parabola for us. And so that's summarized on the next page, which has that diagram at the top in number 4. X squared equals 4py, and then vertex focus. Right here, that D, I probably should have written DIR for Directrix. So maybe do this, so it's not just D, so you don't confuse it with domain, right? So then next, so in number 4, it says, what happens if you switch the x's and the y's? Right? Well, if you switch all the x's and y's, you don't get x squared equals 4py. You get y squared equals 4px. And that means the vertex, if you switch the x's and y's, well, 0, 0 switched is still 0, 0. So that doesn't really change anything. The focus, instead of 0p, if you switch x and y, you get p0. And then the directrix, if you switch x and y, instead of y equals negative p, you get x equals negative p. So let's draw a picture of that. Right? We got a vertex still at 0, 0. Vertex at 0, 0. We got a focus at p0. So let's say that's here. Right? That's going to be on the x-axis somewhere. So focus is p0. I'll put a little x for this one too. And then, let's see, the directrix is x equals negative p, so that would be a vertical line instead of a horizontal line back here somewhere. X equals negative p, where this distance and this distance are the same. They're both p. Okay, and then we know that it's got to open up towards the focus, so our parabola looks something like this now instead. So it turns out it's got a sideways parabola when you've got a y squared equals 4px, and you've got a normal looking parabola when it's x squared equals 4py. Okay, so this number 4 here, by the way, is super key to the entire whole unit on parabolas. Anytime you're in doubt, come back to number 4 and reference this. This is huge. So this equation is for a parabola that's sideways, which really means it's either going to open to the right or to the left. And then this is going to be for a normal parabola, which is either going to open up or down. Okay, so let's try 5. Okay. In fact, let me do this. Somewhere, do I have this? Yes, I do. Oh. Paste. All right, I actually summarized the info in a bubble right there. Parabola that opens up and down, x squared equals 4py. I'll make this a little bit bigger. So here we go. This is our cheat sheet right there. All right, so for this one, we've got a directrix at y equals 2. So we'll draw a little sketch to help us with it. Y equals 2 is up here. Y equals 2. In every case that we're going to do for this unit again, vertex is at the origin. So this is going to be 0, 0. Right here is the vertex. So then the focus is going to be down here now, right? Because they have to be evenly spaced. So the focus is going to be at 0, negative 2. And so it's going to open towards the focus like this. So there's our picture. Now that opens down, right? So it's going to have an equation of this form. X squared equals 4py. And the focus is 0p. Well, that's 0, negative 2. So p, this tells us p is going to be negative 2. So then all I have to do now is plug in the p. X squared equals 4 times negative 2y. So x squared equals negative 8y. And then you just stop. That's the equation of your parabola right there. Right? All right, let's try b. Directrix is x equals negative 1. So we'll draw a sketch for it. Directrix at negative 1. That's a vertical line over here. X equals negative 1. The vertex, the vertex, still 0, 0. They're all going to be 0, 0. And that means that from here to here is the same distance as from here to the focus. The focus right there is going to be 1, 0. And the parabola would open like this. Okay, so the parabola is opening sideways. Well, that opens left or right. So that's going to have this kind of equation. Y squared equals 4px. And the focus is p0. So that means p equals 1. So then you just plug in the p right here. So you get y squared equals 4 times 1 times x. So y squared just equals 4x. And there's your equation. Okay, let's try C. So C, notice it already gives you the focus. So this is going to be P0 right here. Right, so we already know P is negative 2. The real question is, does it open left or right? Okay, so let's just draw a quick sketch. Negative 2, 0 is the focus right here. And we know the vertex is here. So it's got to open like this. It's a sideways parabola. So opens to the left, that's going to have this equation. Y squared equals 4px. And p is negative 2, so y squared equals 4 times negative 8. Oh, whoops, sorry, times negative 2. I'm doing too much in my head. Times x. So y squared is going to be negative 8x. Done. Pretty simple. All right. Focus is at 0, 3. Well, that's going to be 0p then. Right? And if you draw a quick sketch, you can easily figure out if this is the focus right here at 0, 3, and this is my vertex at 0, 0, then it's going to have to cradle the focus. So it opens up. And ones that open up have that form. X squared equals 4py. Okay, well, p's 3, so x squared equals 4 times 3 times y, which is 12y. And then we're done. All right, so those should be pretty straightforward. Let's try coming up with an equation instead. Okay, or sorry, not coming up with an equation, graphing them. So I'm going to paste my little cheat sheet again right here. And actually, when you get to this page, if you scroll down, if you look at the bottom, you've got that cheat sheet on your page in big, bold, font there. So I'm just going to have it so that it's easily seen on the screen with us. All right, now notice these aren't in the form that we want them in. So in this case, we want to isolate either the x squared or the y squared term. So let's take a look. Let's get the 1 over 20y squared by itself first. So we'll bring the x over, and then we'll multiply both sides by 20. Okay, so now y squared's by itself. So it's y squared equals something, which falls into that category. So it's going to open left or right. And we know that it's in the form y squared equals 4px. Well, the y squareds match up, the x's match up, so that means that 20 and 4p have to match up. Well, that means p is 5. Okay, and coming back over here to our cheat sheet, well, that means that our focus is 5, 0. So the focus is going to be at 5, 0. The vertex, just like all of them, are going to be at 0, 0. And the directrix is going to be at x equals negative 5. So that's definitely enough to graph the thing. So we've got a vertex at 0, 0, a focus at 5, 0. I'll just do F there for focus. Vertex 0, 0. Directrix at x equals -5, so that's this dotted line right here. And then our parabola opens up towards the focus like this. Okay, we got one more over here. Y equals 5x squared, so let's get the x squared term by itself by first subtracting y. And then we'll divide both sides by 5. Now I'm going to write it like this. -1/5 y. Right there. So now it's in this form. So it's going to open up or down. And so I'll write the general form right below it. X squared equals 4py. Okay, the x squareds match up, the y matches up. So that means the -1/5 has to equal to 4p. Well, if I divide both sides by 4, then I've got -1/20 equals p. Right? Or you could think of it as multiply both sides by 1/4 if that's easier. Okay, and since it's x squared, it opens up or down. Well, then I can use all this other stuff. My vertex is going to be 0, 0. My focus is going to be 0, -1/20. And then my directrix is going to be y equals -p, which is +1/20. So that's enough to graph the thing. So let's go ahead and graph it. Vertex is at 0, 0. Now, I realize if you're using graph paper, you might want to use each box as one. But in this case, you're only graphing a couple of things. Just make the first box 1/20, right? So this right here is y equals 1/20. So here's the line, right? Y equals 1/20. The focus is at, let's see, 0, -1/20. So that'd just be on the other side here. And then the vertex, again, is at 0, 0. And so this is going to open towards the focus like that. Okay, now there's one other part to the problem, axis of symmetry. So that's the axis that goes right down the middle, and it should look perfectly symmetric on either side of it. So in this second diagram, the axis of symmetry is the line going right down the middle here. It goes right through the focus and right through the vertex. Right, so that's that line. Well, that line has the equation, saw right here, axis of symmetry. Okay, well, the axis of symmetry, in this case, everything on that line is x equals 0. Over in part A, here's the axis of symmetry. Right? Well, everything on that line is y equals 0. So axis of symmetry. All right. I hope that helps a little bit, and that wraps up the last of our 4 major types of shapes for this unit.